Turn the video on again. We're going to assume that we have a 100-gram sample. If we have a 100-gram sample, if this is 100 grams, how many grams of it is carbon? 75. And how many grams is hydrogen? 25. Okay? So we can just simply assume that we have a 100-gram sample. We're going to have 75 grams of carbon and 25 grams of hydrogen. If that's the case, and we are trying to find the formula for this, where X and Y are the subscripts, this X and this Y are moles. Do you remember? Okay, they are moles. So, like we were saying before, this is kind of doing what we did with the crayon lab. Okay? If we have moles here and moles here, can we change grams to moles? How do you change grams to moles? Yep, there is a formula for it. What's the formula for changing grams to moles? I'm going to erase this. Okay. So let's take the given mass. I'm just going to write mass. Mass over the gram formula mass. And that's going to give us moles. Do we have a mass for carbon? Yeah. Okay. So 75 grams. And what's the gram formula mass of carbon? 12 grams per mole. And so that's going to give us how many moles of carbon? 6.25. Okay. Now let's do the same for hydrogen. We're going to do grams over gram formula mass equals moles. We have 25 grams. What's the gram formula mass of hydrogen? 1 gram per mole, which means I'm going to have how many moles? 25 moles. Okay, you with me? I need all your brains up here. So what we've done now is we've figured out X and Y in moles. 6.25 and Y is 25. So really what we have is we have C 6.25 and H 25. Okay? Uh-oh. It is ugly. Is that an empirical formula? Nope. And it's not an empirical formula because, bump, 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 empirical formula is lowest whole numbers. Okay? Do we have whole numbers here? No. So in order to get them to be whole numbers, here's the trick. You're going to divide by whatever the smallest number is. So 6.25 divided by 6.25 gives us 1. That's good news. Because then it means I can't reduce it any further. What's 25 divided by 6.25? 4. Now is this an empirical formula? Yeah. What do you mean? You good? CH4. Is that better? Okay. The 1 is not usually written there, but I wrote it there just so you can see where it's coming from. Okay? All right, let's try another one. Let's say we have something that is 52.7% potassium and 47.3% chlorine. I want to find the I want to find the empirical formula for this. Okay? How are we going to do it? I'll do one more with you and then you can try the next one on your own. So, we're going to change 52.7% to 52.7 grams. And we're going to change 47.3% to 47.3 grams. Okay? Now that we have grams, we can calculate moles. Because really what we're looking for are these two numbers, X and Y. Those are a mole ratio. Okay? So moles is going to equal grams over gram formula mass. We know we have 52.7 grams. And what's the gram formula mass of potassium? 39 grams per mole. .7 divided by 39. What the heck? I can't see a darn thing. Let's try this again. 52.7 divided by 39. 1.35? 1.35 moles of potassium. So that's my X. That's this number right here. Okay? Because these are mole ratios. And then let's do chlorine. So we've got moles equals grams over gram formula mass. Grams is going to be 47.3. The gram formula mass of chlorine is 35. It's really 35.5, but let's hope it comes out close enough. 47.3 divided by 35. And we get 1.35 moles of chlorine. So I'm just going to change this. So we've got K is 1.35, and chlorine is 1.35. Okay. These are not nice whole numbers, so we're going to divide by the smallest one. And we're going to get K1Cl1, which is KCl. That's my empirical formula. Easy peasy lemon squeezy? Okay. Try one on your own. Magnesium and bromine. 13% magnesium, 87% bromine. Okay, let's do it and see if you get your right answer. 13%, we're going to make it 13 grams. 87%, we're going to make it 87 grams. We're going to find moles. Moles equals grams over gram formula mass. 13 divided by 24 is going to give us 0.54 moles. So magnesium, that X is going to be 0.54. Bromine, we're going to have 87 grams divided by 80 grams per mole. That's going to give us 1.08 moles. So bromine, that Y is going to be 1.08. So magnesium is 0.54. Bromine is 1.08. These are not smallest whole number ratios, so how do I get rid of that? Divide by the smallest one. And you get magnesium 1, bromine 2. Is that what you got? Okay. Na, S, and O. Okay. So we're looking for the formula for Na with an X, S with a Y, and O with a Z. Okay, we ready to work it out? Did you get an answer? Okay. So I see some of you are seeing what's happening here, except for Mr. Valerio. Never.
No idea.
Okay. Let's change these guys to grams. 32.4 grams of sodium. We got 22.5 grams of sulfur and 45.1 grams of oxygen. Now we're going to change them to moles. Christina, you with us? Okay. Moles equals grams over gram formula mass. We got 32.4 grams over Sodium weighs 23 grams per mole. And so I'm going to get how many moles? Yoo-hoo. What? 1.4? What do you mean something like that?
I got 1.41.
Yeah, all right, 1.4. Okay? Now let's do 22.5 grams of sulfur. What are we dividing that by? What's the gram formula mass of sulfur? 32 grams per mole. This is for the sulfur now. How many moles of sulfur do I have? How many? 0.7 moles of sulfur. Let's label these so we don't get confused. All right, 45.1 grams of oxygen. 45.1 grams divided by oxygen, which is 16 grams per mole. How many moles of oxygen do I have? 2.82. We'll just leave it 2.8. Okay? All right, now we've got NaXSYOZ. Okay? Na, we know the X is going to be 1.4. S, we know it's going to be 0.7. And O, we know it's going to be 2.8. These numbers right here, 1.4, 1.4, 0.7, 0.7, 2.8, 2.8. Those are the mole numbers. But they are not in smallest whole numbers. So what do we do to fix that? Divide by the smallest one, and that happens to be 0.7. So we've got Na2. S is going to be 1, so I'll leave it out. O is going to be 4, Na2SO4. There's my empirical formula. Good? Something keeps catching my eye over there with that shadow, and it looks like, I don't know. All right, last one for today. We're going to look at this one. Now, look at what the percentages are. 25.3% copper, 12.9% sulfur, 25.7% oxygen, and 36% water. Okay? What is this that we are looking for? It's a hydrate. Okay? It's a hydrate. So we've got copper, we'll put the X. We have sulfur, we'll put the Y. We have oxygen, we'll put the Z. And then we have water attached. Okay? We can put an A here if we want. We can put something. Or we can put the number up front because we know it's a whole amount of waters that are attached. These are moles now. Do you understand? Yeah. Okay. Find out how many waters are in this copper sulfate hydrate. How many moles of this water am I going to have when it is empirical? All right. You got an answer yet? Almost? All right, let's do this. 25.3 grams of copper, 12.9 grams of sulfur, 25.7 grams of oxygen, and 36.1 grams of water. Let's change them all to moles. Moles equals grams over gram formula mass. 25.3 over, what's the gram formula mass of copper? No. Yeah, 64, right? Okay, 64 grams per mole. What's 25 divided by 64? 0.39, 0.4? What is it, 0.4? 0.4 moles. Okay. Let's do the next one. 12.9 grams of sulfur divided by 32 grams per mole. 12.9 divided by 32.4. Oh, how convenient. 0.4 moles. Okay. 25.7 grams of oxygen over 16 grams per mole. 25.7 divided by 16. I can't read that. What does that say? 25.7 divided by 16. 1.6. 1.6 moles of oxygen. And 36.1 grams over 18 grams per mole. And that's 2. Okay. I ran out of room here. Cu 0.4, S 0.4, O 1.6, H2O, and I'm going to put an X here. I lied. I'm going to put a 2 there. Okay. How do I get those numbers to be whole numbers? Divide by 0.4. What do we get? Cu 1, S 1, O 4, and 5 H2Os. Now, if you put the 5 here, it's okay. It's just saying there's 5 groups of water. I'm going to rewrite it in the conventional way where it says there's 5 waters attached to it. Okay? Do you see how all this went down? Alright, I'm shutting the video off now.